Hello and welcome to the FullStackDev tutorial series. In this video, we'll be creating GitHub Actions workflows for continuous integration and continuous deployment. In doing so, we'll demonstrate how to combine coverage statistics and display the combined coverage reports in the project Git repository when we create pull requests. In the previous videos, we set up front-end tests and end-to-end tests, and ran the first end-to-end test on our project with Cypress and PyTest working in conjunction. We also provided endpoints to the Flask server that will allow us to make requests to start and stop backend coverage. Before we continue, we'll need to make sure we have committed any changes to the master branch, and we'll also need to create a staging branch. We don't need to make any changes to staging now, but we do need to push it to the repository as well. Once we have configured actions workflows, which we will do momentarily, this will allow us to automatically test any pull requests to the staging and master branches. Now that the master branch and staging branch have been pushed to the repository, we'll create a new branch locally called git_test. In getTest.yml, we'll create the test status workflow, which will be triggered every time there is a pull request to the staging or master branch. First, we'll define the environment, and the strategy matrix will be Python and Node. We'll need to create the log directory and bind the code dev.com host mapping. After setting up the Python and Node actions versions, we'll bring up the test containers and install dependencies. Notice, when we launch the Flask test server, we make the request to begin PyTest coverage. And after running the Cypress tests, we make another request to stop PyTest coverage. And the last two jobs will report the coverage summaries to the open pull request. In getDeploy.yml, we'll create a similar workflow for deployment, which will be triggered when we push commits to the master branch. Notice that our environment will be using production variables, which will need to be encrypted and kept secret. We can achieve this by creating repository secrets from the Settings tab under Security Actions. You can define these to your needs, but keep in mind the do/su value will need to be the same password as the user password that we'll create when we create our virtual server. The main difference here is this workflow runs on self-hosted. We'll create the runner listener when setting up the virtual server, and some of the commands will require sudo privileges, which will be piped from the do/su environment secret variable. We're almost ready to create and set up the virtual server, but we're still missing the nginx config file. Let's create that now. And we'll define some very basic rules for the server, including a proxy pass for the Flask API and the PM admin server. If you choose to use this in production, you can configure your nginx server to your specific project needs, but this will work for the purposes of this series. I'll be using a DigitalOcean droplet to serve the project, but feel free to use any virtual private server provider of your preference. There are many alternatives to choose from. As you can see here, I've created a droplet using the latest Ubuntu version. We'll need to take note of the IPv4 address, as this will be required in our getDeploy workflow environment, as well as the nginx server name field. And don't forget to allow the required ports through the firewall from the network settings panel. There are a couple of ways to get a console for your server depending on how you set it up. Here, for example, we can always get into the console from the Droplet UI. Once connected, some basic information about the server is shown, and you should have access to the CLI. I've already installed the required packages on this server, but for future reference, I'll create a file with the steps needed to achieve the proper server configuration and include it in the project repository so we can easily repeat the steps in the future. You can follow these instructions from your repo action runner settings for the up-to-date runner version and the proper API token for your personal project repo. We're almost ready to push changes to the Get repo, but I have found a few settings and errors that will need to be addressed before our tests will run properly. In Get Tests YML, the Studio environment variable should be FSD environment, and GitHub Actions used Docker version 2 now, so the Docker compose command should not be hyphenated. Also, the reporter work directory should be modified to the project name instead of the abbreviated version. And in the server requirements file, we're missing the rmpycache library. Lastly, we'll need to give the coverage reporter access to write the coverage summary to the pull request by modifying the actions setting. Now we should be able to add the staged changes, make the commit, and then push the commit to origin. We can see here that the new branch was created successfully. So we'll select Compare and Pull Request. From here we'll need to set the base branch to staging and create the pull request. After a few seconds, we should see test status in progress. We can expand into the process by clicking Details and following along if we'd like, or we can simply wait for feedback on the results, which will either yield errors or a completed status. And here we can see that the tests have passed, and we have a nice green check mark. Back in the pull request to staging, we can see the reporter has commented the pull request with the combined coverage reports. When we run coverage for the end-to-end tests, we can see that PyTest coverage is at 82%. Whereas when we run just the PyTest for the back end only, the coverage is only at 72%. So we can see that the end-to-end tests are giving us a more accurate look at the actual coverage of the entire application. At this point, the automated testing workflow seems to be working as intended. In a real-world scenario, I'd like to see coverage thresholds a bit higher, but for the purposes of this video series, we're going to call this test run a pass, and given the nice green check marks, we'll go ahead and merge the Get Test branch into the staging branch by clicking the Merge Pull Request button and confirming the merge. Now back in the repo main page, we can click on Compare and Pull Request. We'll be creating another pull request, this time from staging to master, which will trigger another round of tests. This may seem a bit redundant, but when working on a team where other developers are trying to get their changes staged and merged to the deployment branch, it's important to check each pull request for bugs and errors. As before, all the tests passed. And again, we have nice green check marks. So we'll go ahead and merge the staging branch into the master branch. But this time, instead of triggering a test run, this will trigger deployment to the live virtual private server. I've looked ahead for any errors we might run into during deployment and found several things that should be addressed before our get deploy workflow will run properly. The indentation in the get deploy YML file is off and will throw an error, so let's fix that first. And like it was in get test YML, the studio environment variable should be FSD environment. Also, the deploy workflow is looking for the Flask server service daemon config, and we haven't created it yet. We need to do that now. Again, as in the get test workflow, the docker compose command should not be hyphenated. And lastly, we haven't purchased an actual domain name, and our deployment will be running solely from the IP address. This will break any default SSL configuration in the Nginx config. We'll be adding a domain name and a security certificate in a future video, but for now let's configure the server to run HTTP only. I'll be pushing these changes directly from the master branch to purposefully skip the testing process and instantly trigger the deployment. Here we can see all of the jobs were completed without error and the deployment was successful. And when we navigate to the IP address, we should see the live production version of the application up and running. Fantastic! We now have a live site. Although, there's still some work to be done. We haven't created the database tables yet, and the connection isn't secure because we are not connected over HTTPS and obviously we don't have a proper domain name. But this covers the core concepts of creating a full-stack application through automated testing and deployment. In the meantime, for good practice, you can try to bring the coverage up on the front and back end by writing more tests. You could also create the base database tables on the live server. Later on, I'll be making more standalone videos on how to secure the live site with Let's Encrypt to issue a security certificate and enabling SSL. We'll also go over providing a proper domain name and the steps to do so. We'll cover how to make changes to the database models and run migrations on the existing tables, and how to integrate Cloudflare into the site for added security, statistics, and better performance. And with that, this is a good place to end this video series for now. I hope this has been a positive learning experience and helps along in your coding journey. As always, thank you for watching the FullStackDev tutorial video series. If you have found these videos helpful in any way, please like and subscribe to the channel. See you again soon.